Hi students, today we will see comparison of rational numbers. You know that rational number is in the form p upon q or m upon n and the denominator should not be 0. If it is in the form m upon n, then the condition is there that n should not be 0. We know that for any pair of numbers on a number line, the number to the left is smaller than the other. Also, if the numerator and the denominator of a rational number is multiplied by any non-zero number, then the value of rational number does not change. It remains the same. That is, suppose our fraction is a upon b or the rational number is a upon b, and if we will multiply the numerator and denominator by k, then a upon b is equal to k multiplied by a upon k multiplied by b. Here one condition is there, k is not equal to 0. If you will see a upon b is equal to ka upon kb, then k is same here, so it will cancel with each other. So a upon b is equal to a upon b, means if we will multiply or divide, we will multiply both the numerator and denominator by same value, then the rational number, it does not change, it will remain as it is. Now they given one example here. Comparison means one number is greater, other one is smaller, otherwise the both the numbers are equal. Now compare the numbers 5 upon 4 and 2 upon 3. While comparing the numbers, what you have to do, in previous year you have studied how to compare the rational numbers. Now look here, how to make the denominator equal, that also you have studied. Now here they given the two rational numbers 5 upon 4 and 2 upon 3. We'll make the denominator equal. How to make it? See here, 5 upon 4, if we'll multiply 5 upon 4 means by numerator and denominator by 3, then you will get the rational number 15 upon 12, means 5 multiplied by 3 is equal to 15 upon 4 multiplied by 3 is equal to 12. Now another rational number is 2 upon 3. Here also we have to make the denominator of this number is 12, because we want the equal denominator of both the rational numbers. Then easily you can compare the numbers. So when you will multiply 3 by 4, you will get the denominator 12. So by that same number you have to multiply numerator also. So 2 multiplied by 4 upon 3 multiplied by 4 is equal to 8 upon 12. So we change this 5 upon 4 into 15 upon 12 and 2 upon 3 into 8 upon 12. If you will see, 15 upon 12 is nothing but 5 upon 4, because 3 5s are 15 and 3 4s are 12. Same way 8 upon 12 means 2 upon 3. Means if you will find the reduced form of these two rational numbers, then again you will get the same numbers as 5 upon 4 and 2 upon 3. Now let us compare within that numbers 15 upon 12 and 8 upon 12. When the denominator is equal, you can compare the numerators. So here you can compare 15 and 8. If you will see here, then you will get that 15 is greater than 8 or 8 is smaller than 15. Therefore, the fraction 15 upon 12 is greater than 8 upon 12. Therefore, the original fraction 5 upon 4 is greater than 2 upon 3. Now, one more example they given here. You have to compare the rational numbers negative 7 upon 9 and 4 upon 5. You know that a negative number is always less than a positive number. Therefore, here easily you can get the answer of these rational numbers. That is, negative 7 upon 9 is less than 4 upon 5. While comparing the two negative numbers, we will see that the number on the number line and which is nearby 0, that is greater than the another negative number. So if we will consider the numbers negative 2 and negative 3, the number negative 2 is near than 0 as compared to negative 3. So, negative 2 is greater than negative 3. Now, we will see the fractions or the rational numbers 5 upon 4 and 7 upon 4, as well as negative 5 upon 4 and negative 7 upon 4. Here, you will see that the denominator of 5 upon 4 and 7 upon 4 is equal, that is 4. So we will compare the numerator. Here 7 is greater than 5. So the rational number 5 upon 4 is less than 7 upon 4, or you can say that the rational number 7 upon 4 is greater than 5 upon 4. But if we will compare negative 5 upon 4 and negative 7 upon 4, then you will get that here negative 5 is near the 0. So while going from on the number line, while going from left to right, number increases, and going from right to left, number decreases. So negative 5 is greater than negative 7. So the rational number negative 5 upon 4 is greater than negative 7 upon 4. Again they given one more example there. You have to compare the rational numbers negative 7 upon 3 and negative 5 upon 2. Here if you will see these two rational numbers, then the denominator of first number is 3 and the second one is 2. So first we have to make the denominators equal. For that we have to find the LCM or the same number between these two tables. Means here 3 and 2. So the same number in between these two tables is 6, as well as 12 also, 18 also. But we will take the first number which occurs. Then 7 upon 3 is equal to 7 multiplied by 2 upon 3 multiplied by 2 is equal to 14 upon 6. And 5 upon 2 is equal to 5 multiplied by 3 upon 2 multiplied by 3 is equal to 15 upon 6. If we will see the rational numbers 15 upon 6 and 14 upon 6, then 15 is greater than 14. So 15 upon 6 is greater than 14 upon 6, or 14 upon 6 is less than 15 upon 6. Therefore 7 upon 3 is less than 5 upon 2. But if the both numbers will contain negative signs, then therefore negative 7 upon 3 is greater than negative 5 upon 2. Now again they given the fourth example, that is 3 upon 5 and 6 upon 10 are rational numbers. Compare them. Now look, in 5's table 10 comes. So 5 2's are 10. So just we will change the rational number 3 upon 5. 3 upon 5 is equal to 3 multiplied by 2 upon 5 multiplied by 2. You will get the rational number 6 upon 10. Therefore 6 upon 10 and 6 upon 10. So 3 upon 5 and 6 upon 10, these both rational numbers are equal. Now they given some rules which are useful to compare the two rational numbers. Suppose or if A upon B and C upon D are rational numbers such that B and D are positive, and if they given the three conditions here, if A multiplied by D means they have multiplied the numerator of one number and denominator of second number is less than B multiplied by C, then the fraction a upon b is also less than c upon d, or the rational number a upon b is less than c upon d. Second condition is, if a multiplied by d is equal to b multiplied by c, then both the rational numbers are equal. Means a upon b is equal to b c upon d. Now next condition is, if a multiplied by d is greater than b multiplied by c, then you can write that a upon b is greater than c upon d. These are the rules to compare the rational numbers. Okay, maybe you have understand it well. Now solve the exercise depend upon this, or the problem set depend upon this. Thank you and bye.